So we just did our math workshop. That was number 1. So today's notes are going to be number 2. All right. Tucker, can you tell me what my learning target is for today?
I can create a tape diagram to solve ratio word problems.
Excellent job. So our goal today is to be able to create a tape diagram. Do you know what a tape diagram is right now? No. Okay. So guys, that's our goal today. When you leave today, not only will you be able to, not only will you know what one is, you'll know how to create it and use it to solve ratio word problems. Ratio word problems. When have we heard about ratio word problems? Raise your hand if you can tell me. Ashton?
We heard it when we started doing
Yeah, we heard it when we started doing ratios. How long have we been talking about ratios and rates and unit rates and all that fun stuff, Ben? Like a long time, like 3 weeks of time, okay? So what we're doing today, guys, is going to be really review from what we've been doing, but it's going to give us a visual representation for these ratios we've been working with, okay? So our goal here is visual representation. Yes, Sadie?
Is there going to be a blog?
There will be some charts. If it gets to be too much, just stop, pay attention, and I'll get you a copy of the notes. Okay? If it starts to be too much, just pause. Okay? All right. On our notes for today, you'll notice it says the problems that we're going to be doing are from page 178 and 179 of the student textbook. Now, we don't have our textbooks with us in class, so while you're getting that copied and set up, I'm going to go ahead and pass out our paper for today because I just made a copy of those textbook pages, so we'll be able to use them. All right, the benefit of this is we don't waste our class time copying word problems, and we can work on doing word problems. So take one, pass it back. I got way too few. There's 4. Just pass all those back. I forget how many of y'all there are in here. Yeah, this is going to go with your notes. Guys, you're also going to do your homework from here. All right, so you don't need to number it and put it with your notes because it's really going to go with our homework. All right, extras or too many? All right, just pass it over this way, please. Thank you. All right, everyone else has one? Do we all have one? Yes, ma'am.
Do we also label it too?
No, ma'am. All right, you do not need to label this as number 2 because this is going to go with our homework. Okay, good question. All right. So, guys, we're going to start off by looking at number 1. So, on page 178 of your textbook, you would see number 1. All right, guys, the worksheet that I just handed you is a copy of page 178. So, if you look down here in that bottom corner, it says 178 because that is the book page that this is from. So, let's see if we can get this all lined up. All right, so for number 1. All right, guys, remember, a ratio is comparison of 2 quantities, correct? So we should be comparing stuff. Now, when we're doing these problems, we're going to be talking specifically about equivalent ratios. Can someone raise their hand and remind me, what does an equivalent ratio mean? What does that mean, Ashton? Yeah, like an equal ratio. So like we could have 2 over 4 and something, give me a ratio that would be equivalent to 2 over 4. Amelia?
2 over 1. 1 over 2.
1 over 2, so 1/2. So 2 over 4 and 1/2 would be equivalent. 2 over 4 and 10 over 20 would work. All right, so equivalent means when we simplify them down to the most simplified form, they would match. All right, equivalent also means that when I get a unit rate, their unit rate should be the same. If they're equivalent, if they're equal, their unit rate should be the same. It should be equivalent as well, correct? All right, we're going to be using that knowledge to make these tables. Now remember, guys, our goal here is visual representation, right? So we're going to be drawing. A tape diagram could also be called a bar diagram. All right, so we're going to be drawing some bars to represent these ratios. All right, so let's look at number 1. Number 1 says, suppose it took Jill 18 minutes to complete 6 laps. How many minutes would it take Sammy to complete the 3 laps if she raced at the same rate as Jill? Guys, where it says that same rate, that's how I know these are going to be equivalent. All right, so real quick, we have 2 measurements there that are measuring the same thing. What 2 numbers are measuring the same item? What 2 numbers are measuring the same item? Neely?
6 and 3.
6 and 3, because 6 is measuring laps and 3 is measuring laps. All right, now are 6 and 3 in the same ratio? Raise your hand. Are 6 and 3 in the same ratio? Sean? No. They are not in the same ratio, but what is important is that they are measuring the same thing. They're both measuring laps, okay? They're measuring the same measurement, if you will. All right? So let's talk about that 6 first. We're going to draw out a bar to represent those 6 laps. So guys, what I've done is I just drew a vertical line and a horizontal line because I want to try to make my boxes match. So on this bar, we're going to split it into 6 boxes. So 1, 2, 3, 4, 5, 6. And the reason I just do the top part is because it's really easy to add more onto it if I need to. All right? And then I'm going to fill that in that bottom one. So do you see how basically I created a bar and it split into 6 different sections? Can we see how that worked?
Yes.
All right, what are these 6 boxes representing?
The 6 laps that Jill took.
These are representing the 6 laps that Jill took. So we could even write Jill over here so we know it's Jill. Okay. So what does 1 box represent? Raise your hand if you can tell me. What does 1 box represent, Andrew?
1 lap.
1 lap. Perfect. So 6 boxes here for 6 laps, which means 1 box is just 1 lap. Okay. So now we're going to do the same thing for Sammy. How many laps did Sammy go? 3. Sammy went 3. Now, guys, I'm going to try to draw my box under here matching exactly. Because their laps, they're running around the same track, okay? So their laps are going to be the same size. So I'm just drawing it underneath, trying to make a match up. Is it perfect? No. Can you kind of see, can you see what we're going for, though? My top 2, those match, those match, those match. So that's our goal here. Okay, so what do those 3 boxes represent? Brittany? The 3 laps that Sammy ran. And 1 box, of course, would be? 1 lap. Okay? All right. Now, guys, right now, we don't have a ratio. But in this problem, there was a ratio. Can someone tell me where was my whole complete ratio that I was given in this problem? The complete ratio. We were given 1 complete ratio. Jessica?
18 and 16.
Close. 18 and?
6.
18 and 6, yeah. All right, so we had 18 minutes and 6 laps. Do y'all agree that that 18 minutes and 6 laps go together?
Yeah.
All right, that forms 1 ratio. So when I'm talking about these 6 laps, it's important that we put my 18 minutes on top because that goes with that ratio. Minutes. If I could spell, that would be awesome. Just ignore a little mistake there. Okay. So we have 18 minutes for 6 laps, yes?
Yeah.
All right. Now, right now, knowing that it took Jill 18 minutes to run 6 laps doesn't help us a whole lot for the 3 laps, besides the fact that, obviously it's half, but we're not worrying about that right now.
Yes.
We still want to fill in our whole visual representation. So if I take these 18 minutes and I split them into each of these boxes, again, someone remind me, what does 1 box represent?
1 lap.
1 lap. So if I take that 18 and split it up, it should tell me how long it takes to run each lap. 1 lap, which is called a unit rate. Oh my goodness, awesome. Thank you, Sadie. Yes, good job. Okay. So if I'm splitting it up, what operation is that? Splitting something up. Sean, thank you for raising your hand so much. division. If I'm splitting it, it's division. How am I splitting this up? By what number? 6. So I'm going to do divided by 6 because we said splitting, division, into those 6 boxes. So how many minutes is that going to be? Lily? 3 minutes. 3 minutes for what? For 1 lap. Do y'all agree with that? That's 3 minutes for 1 lap? Yeah. All right. So that means each of these boxes we get 3 minutes. So I'm going to put 3 and then MIN for minute. And I'm going to put that in every single box here. I don't know why I put a bar there. Ignore that. I did it again. I'm not going to worry about it, okay? All right, yes?
Would you just write an arrow going through all boxes?
I could. Let's just fill them in, though. Make it look nice and pretty. I like them all to be filled in. Nice and neat. All right, but yeah, technically, I guess we could draw an arrow. You know, you want to skip some corners. Okay. All right, so let's make sure everything adds up. We know each of these boxes represents a lap. And if I add up those 3 minutes in each box, how much do I get?
18 minutes.
18 minutes. Isn't that what we were given?
Yes.
So does all of that information match up with that ratio? Yes. Now, guys, this information is going to help me with Sammy's. Because Sammy's tape diagram is not complete, is it? We're missing a lot of stuff. But Sammy was running at the same speed as Jill. She was running at the same rate as Jill. So how long would it take Sammy to run one of the laps? Sadie?
3 minutes.
3 minutes, because they're running at the same rate. So then how long did it take Sammy to run the next lap?
3 minutes.
3 minutes. And then the next lap? 3 minutes. So when I'm trying to find out how long it took Sammy, what do we get? Brittany? 9 minutes. And then I'm going to add a little bit to that. That's the main thing. That's our answer that we're looking for. But what did it take her 9 minutes to do? To run 3 laps. Okay, awesome job. Number 1. Check. Yes, Andrew?
So do you have to
We've got to show the chart because our whole goal here is doing these tape diagrams. Our whole goal is to show this visual representation. It's showing where it's splitting up, how that 3 minute, that unit rate splits up into each box. All right? Because really, we've done this math without the boxes, haven't we?
Yes. Yes.
Yeah, we've done the math. Now we're just creating that visual representation to go with it. In hindsight, probably should have done the visual, then done the mathematical. You know. But we did it the opposite. It's fine. Right? Annalise? Absolutely. All right. Number 2. Number 2 is hard. We're going to have to put in our thinking caps. Is everyone ready? I need your brain to be in full function mode. Okay? Because we've got to write math. Go ahead, Annalise. It tells us, explain how you can use unit rates to solve for missing measures in equivalent ratio problems. All right, so we need to explain how unit rates help us solve equivalent ratio problems. All right, so guys, thinking back up here, we knew these were equivalent because it says Sammy ran at the same speed, right? If Sammy wasn't running at the same speed, could I have found out her time? Could I have found that missing measurement? No. So can someone tell me, how did the unit rate help me, and why did they have to be equivalent ratios for it to help me? Andrew?
So, unit rates can help explain how to solve it because it tells you, like, how much is going to go in each square, so therefore it helps you find out the answer to the problem.
Okay. And why was it important that my ratios were equivalent?
They would have to be equivalent because if they weren't equivalent, then it would be impossible to find the answer.
Okay, so I like what Andrew said. He said the unit rates let us know what to put in each square. All right? And if it wasn't equivalent, could it have gone in the squares of both diagrams? No. Okay, so we need to kind of put that into words, saying that our unit rate lets us find out what goes in each box, and because they're equivalent, it can go in both of my diagrams. Okay, so I need like basically exactly that in one sentence or two sentences. Someone think they can put that together for me? That's exactly what we just said. Andrew said it perfectly. We just added a little bit in just now. This is challenging. What was the first thing that we just said? What did the unit rate allow me to do? Tucker? Neely?
Find the minutes to each slot.
Okay, so it let us find what goes in each of the boxes, correct? It let us know the minutes for each lap, which let us know what to put in each box, okay? So let's put the unit rate allows us to find the, what's a fancy word to say the number?
Portion.
Amount, we can say to find the amount. That would work. I was looking for quantity, which is the same exact thing as amount. Down to me, I love that word quantity. It just sounds fancy. All right, the unit rate allows us to find the amount in each box of a tape diagram. Okay, so that's what the unit rate allows. Now, why was it important that it was equivalent? Andrew?
Had to be equivalent, because if it wasn't equivalent, then it'd be very hard to find the answer.
All right, so it must be equivalent ratios to be applied to both diagrams. Okay. So the unit rate allows us to find the amount in each box of a tape diagram. It must be equivalent ratios to be applied to both diagrams, thus allowing us to find the missing measurement. Okay. All right, so y'all did really well. All right, guys, while you're finishing copying that, I have a couple of others that were given, that were created in the other classes. All right, this was just last period. We said since the ratios are equivalent, the unit rate from the given ratio will also apply to the ratio with missing measures, allowing us to find the missing quantity. Since the ratios are equivalent, the unit rate from the given ratio will also apply to the ratio with the missing measurement, allowing us to find it. This one's a little bit longer. By splitting up our ratio into groups, the unit rate allows us to find the rate of one group. Since the ratios are equivalent, this unit rate applies to all of the groups, thus allowing us to find the missing measurement. All right, every single time, do you see how it's telling me every single time we have to find the unit rate, which goes in each of the sections, and that the equivalent ratios are what allow it to go to all of the boxes, and then that going to all of the boxes lets us find the missing measurement. All right, and there were a million different ways you could word that. All right, but those are the main things we're looking for. Are there questions about number 2? That one's hard. All right, you really got to think. Guys, my recommendation for you is just like in your English and reading classes, if you're stuck, just start writing something. Just start writing. And then look back over what you wrote. Look back over your thought process and see if you can pick out the things that are actually making sense. Does that make sense? All right, so it's just like they say in English. You're not going to get started until you actually start. So just start writing and then look back and see what actually came together. Okay? All right. Let's look at number 3. Whew. Number 3. I know some of us are still looking at number 2 and writing down our ideas. So I'm going to move that up and give you a second to get number 2 finished up. And I'm going to get number 3 to where I can put it up there. Yes. See?
Just give it to the little one that works, because it's cut off a little bit on the right. Yeah, measurement's cut off.
Is that good?
Yeah.
Okay. Whew. All right, guys. I want you to look real quick while some of us are finishing up. So those of us that are done, I want you to look at number 3 and 4, and I want you to go ahead and look at 10 and 11. What do you notice about all of those tape diagrams? What number is in all of those tape diagrams? Amelia?
1.
1. Now, is that 1 my unit rate?
No.
No. So, guys, the way that we're actually applying these diagrams is like a teensy tiny bit different than the way the book does it. Guys, it's the same thing. We're still applying that tape diagram, just we're not putting the unit rate above or below it. We're actually putting it in the box, okay? So, I don't want us to use their boxes. We're going to draw our own because what do we want in the box?
Our word.
Hand. Let me see a hand because I got a lot of words coming at me. Ashton? What is it we want in the box?
We want some 1 ounce in every box.
No, we don't want 1 ounce. That's what they had. That's not what we want. That's why we're doing our own. What is it that we want in the box? In the box. Sean? We want them to be equivalent, yes. Don't make me a little nervous. Tucker? The ratio, a specific type of ratio. Sadie? The unit rate. We want the unit rate in the box. Unit rate in the box. Okay? All right. So let's look at number 3. All right. It tells me a 5-ounce package of snack mix has 250 calories. How many calories are in a 3-ounce pack of the same snack mix? All right, so again, the first thing I want to know is what are my 2 matching measurements? What are my 2 numbers that are measuring the same thing? Sean?
5 and 3.
5 and 3. 5 is measuring ounces. 3 is measuring ounces, which means that's going to tell me how many ounces and how many boxes to draw. All right, so my first bar diagram or my first tape diagram, how many boxes do I need to split it up into? Noah? 5, thank you. So we're going to have 1, 2, 3, 4, and 5. Trying to draw them as evenly as possible. Doesn't have to be perfect. All right, and again, what did those 5 boxes represent? Brittany?
Ounces.
Specifically, 5 ounces. Okay, and my next bar diagram or tape diagram, how many boxes do I need that one to be split up into, Gabby? 3, and I'm going to try to draw my 3 matching the first 3 from those 5 ounces. Okay, so and that was 3 ounces. All right. Now, we haven't yet really talked about the full ratio. So one of those, either the 5 ounces or the 3 ounces, is actually part of a complete ratio. Which one is part of a complete ratio? Owen? The 5 ounces. And where does it tell me that 5 ounces? Where does it tell me the rest of the ratio?
250 calories.
The 250 calories. It says 5-ounce package of snack mix has 250 calories. And again, that 250 calories and the 5 ounces needs to stay together because it's part of one ratio. Those have to be together. The 5 ounces is compared to the 250 calories. Okay, so we're going to put 250 calories. All right. Now again, guys, we don't really care that the 5 ounces is 250 calories. Our goal is to find out how much just one of those boxes is. What does one box represent? Raise your hand if you can tell me. One box, what does it represent, Ben?
1 ounce.
1 ounce. Yes. Yes. So one of these boxes is one of the ounces. All right, and I want to split up my 250. Sorry, I got a little excited, did a little dance with that. All right, so I want to split up my 250 calories into those 5 boxes. So again, what operation are we going to be doing there, Mark? Division, what am I dividing by? By 5, and that gives me 50 calories. I heard some people say ounces there. I heard some people say calories. If I'm splitting up calories, it better still be calories. All right. Now, guys, by splitting those into 5 sections, that those 50 calories goes in what? Gabby? 1 ounce. Almost like turned and coughed on Tucker. That'd be bad. Okay. So now, what am I going to put in each box? 50 calories. Now I'm just going to put CAL. So 50 calories, 50 calories, 50 calories, 50 calories. All right, let's make sure that makes sense. There are 50 calories in each of those ounces, which is 5. If I add them up, does it give me the appropriate amount? Yeah, 50 plus 50 plus 50 plus 50 plus 50, or 50 times 5 is 250. All right, so guys, it's the same snack mix, right? Did it say it was a different brand?
No.
Different type? No, it's still the same. And look, it says right here, same snack mix. That's how I know it's equivalent. So how many calories is it going to be in 1 ounce of the smaller package?
50 calories.
50 calories. Okay, so now, how many calories total is in the smaller 3-ounce package of snack mix? Addison? 150 calories. All right, again, that's the important part. That's our main answer. But we want to say in a 3-ounce package of snack mix. Alright, so some of us are finished at number 3. While you are, let's go ahead and look at number 4. Get my paper set up so we can see them both. Got this folding technique down now. Okay. Raise your hand if you still need more time on 3. Cleaning. A cleaning solution requires 2 capfuls of cleaner for 4 quarts of water. How many quarts of water are needed for 6 capfuls of cleaner? Now, one thing that I found out today is some of us as 6th graders don't realize that a capful is a measurement. Right? Has anyone helped or watched their parents do laundry? Right? You take your laundry detergent and you pour it into the cap, generally, and then you take your cap and empty it into the washer. All right? Guys, the same thing applies for, like, if you're mixing up water to, like, mop the floor with. Like, you don't just pour the soap in there. You actually pour it into the cap, and the back directions usually tell you how many capfuls to measure out. So a capful is actually a form of measurement for many cleaning supplies, okay? So in this case, we need to first of all decide what are our measurements that match. What are our measurements that match, Joey? 2 and 6, because they're both talking about capfuls. So my first bar diagram is going to need how many boxes? 2. Awesome job, guys. And then my second bar diagram needs 6. And remember, these are talking about capfuls. I don't know why I drew that out weird that time. Okay, so we have 2 capfuls and 6 capfuls. All right, now again, one of these is part of a complete ratio. Which one is part of a complete ratio? Let's go with Bella. Which one of those is part of a complete capful? Ratio. 2 capfuls and 8 quarts. There we can see the 8 quarts has to stay related to my 2 capfuls. Look, I just moved that to where we can't see it. There we go. So my 8 quarts has to stay related to my 2 capfuls. So I'm going to write that up above there. All right. Now, I really only want to know how much 1 capful is. So what do I need to do to find that? Jessica?
You need to divide 8 by 2.
Divide 8 by 2, which gives me 4 what?
Capfuls. 4 quarts.
4 quarts. Remember, if I'm splitting up 8 quarts, that better still be measuring quarts. All right, and those 4 quarts go in 1 capful. All right, because it's just like dividing the top and bottom by 2. 2 divided by 2 would give me 1. 2 divided by 2 would give me 1. All right, so now what needs to go in each of those boxes this time? Andrew?
4 quarts.
4 quarts, and I'm going to put QTS. 4 quarts. Okay. So guys, looking over here, what does one box represent again? Ben?
1 capful.
1 capful. So 1 capful is 4 quarts. It's the same cleaner. Same cleaner. So how many quarts are in this 1 capful? Ben?
Wait. 1. No, 4.
4. So this is 1 capful, which has 4 quarts. And then this box is 1 capful, which has 4 quarts. This is 1 capful that has 4 quarts, and that happens for each of these boxes. Each box represents 1 capful, and 1 capful holds 4 quarts, which is shown right there in that unit rate. All right, so how much is that going to be? Williams, how much is that going to be? 24 quarts of what? Right? So look up in the word problem. Let's find. So there's 8 quarts. Quarts of water. Read the problem. It says quarts of water. And then if I look at the question, how many quarts of water? Do y'all see where I'm getting that from? So that should be 24 quarts of water. Then it says how many quarts of water are needed. So I'm going to say are needed for, and guys, I'm literally just getting this directly from the question, for 6 capfuls of cleaner. So I'm going to write that. For 6 capfuls of cleaner. All right, again, the important part that gives us our answer, that measurement that we were missing was 24 quarts. Move it over so we can see that. Okay. Yes, Andrew?
To make sure your answer is correct, multiply the unit rate by the number that's on the second chart.
Yeah, exactly, guys. So this is what we were doing like last week. Was we were finding the unit rate. So I might give you something like this where I told you, hey, it takes 8 quarts to do 2 capfuls. You would find the unit rate and then you just multiplied that. Remember, we would do like times 6 times 6. Isn't that really what we're doing here? Just now we also have the visual representation. Okay? All right. So what we're going to do now is you are going to use the rest of our time remaining to continue working on numbers 5 through 11.